This year, I would say probably like 90+% of code that I have written, I have not written. Most of the time I'm dictating voice commands and then looking at the code and trying to understand the system design.
%90 of the code Krzysztof has written, he hasn't written. Design, review, prompt, iterate. For developers, this is the new workflow, but it doesn't feel like this is common knowledge, not yet. And what are the implications to the systems and the products that run on probabilistic instead of deterministic code? AI output is chaotic by design. This means the same prompt, a different result. Krzysztof's answer isn't to fight that, it's to build systems that create that determinism around it.
Like it's the system design where the complexity lies. And that's how it worked, right? So I focus my effort on the system design. And with AI, I can basically do it at a much bigger scale. The way I work with AI does not differ much from the way I work with engineers that are less experienced. That's how I think about it. And I think that's the best way to think about it. Because the hard thing for me to come up with, and for like an engineering project, is like, how do we design this system? Like, how do we create a nice architecture? How do we make it maintainable? Claude seems to be better at design than Codex, but Codex is better at the actual hardcore programming stuff.
If you're running Krzysztof's setup, development is a process of adding structure around these foundation language models. Here's an example. For one client, he built an orchestrator that downloads tickets, generates PRDs, that's AI, implements the code again, AI, creates the pull requests, AI, to ensure that the models work every time. Between each step, there's a test. So the AI creates, but the system verifies.
So for one of the clients, I have this orchestrator that downloads the tickets from Litter, builds PRD using one of the CLIs, reviews the PRD. Once it seems reasonable to both models, it sends it back to Linear. The programmer looks at it. The programmer says, okay, it's fine or not, or give him requests to change something. And then they change a tag and the tool downloads that and implements. The connections between those things are deterministic because they are not using LLMs. It's just LLM is doing the implementation or the review, but the forcing of you always have to do a review, you always have to build, you always have to test. It's all deterministic. Once it implemented it once, what it does, it first reviews it with a completely different context, different system prompt, different context, then feeds that back to correction. Then it goes again, reviews it. This sounds like a graph, right? So it's like loops until there's nothing major left. You can add a post hook and be like, have you read the rules? Is this code following the rules? And then it assesses it and fixes it if it doesn't. So it's a longer session between when you start and when you look at the code. But I think it's better because I don't want to look at a code that doesn't build, that has obvious mistakes.
And once you have that approach, once you deal with AI's fundamental constraints from hallucinations to low probability outputs, once you solve that in your architecture, you can begin to make the most of its strengths.
What AI allows us to do is I can run 5 different sessions on 5 different work trees with slightly different description of how I want to build something. And I'm going to get 5 different implementations. And if I don't like either of them, I can spend hours working on that refactor. I'm better informed, have less stakes, because if you are writing this manually and you spend 3 days writing this massive refactor, then you realize, it's kind of messy, but I already spent so much time and I need to deliver. Then you are more likely to be like, okay, it's going to be fine. Whereas when I'm using AI, it's not about being fine. It's like, is this better? It's like, is this the best I can do right now? It used to be that you would write a doc describing your idea for a feature you want to try, right? And only then when it got approved and someone agreed that it's a good idea, you would actually get the time to implement it. Well, now that's not necessary. You can just talk to LLM on a work tree on your project and like, oh, I want this feature in this to work in this. And maybe you spend an hour or 2 on it, reviewing it, and you have it in your hands and you can show it to people. And if it's a good idea, the likelihood of you actually getting people convinced that it's a good idea when you have it in your hand is going to be a much higher level than it used to be with a document. That's a huge advantage, right? Huge advantage.
If you can create systems to control the unpredictability of AI output, as Krzysztof has shown, you can quickly spin up features and products to test and validate. But whether you're using AI to write the code or as a central component of your code, you need a framework which guarantees a predictable result from an unpredictable model. AI handles the generation, the system design handles the AI.
Peter Steinberg is a friend. He also talks a lot about AI, and we've had a bunch of discussions about it as well. And he says the same. It's like, he tries something, he doesn't like it. It's like, well, whatever, I'm going to try something else. And there's no attachment to the code being written. The attachment is in the experience of the user. Does it make sense for the user or not? And does the code work? Is it readable, right? Those are the metrics I care about.